So now that we've learned about passing by value and passing by reference, let's see if we can write a short program that passes different data types into a function. We're going to start with arrays. So I'm going to start with an array that has 5 elements. I'll just put some random values in there, and then we're going to write a function that is going to square each one of the individual elements of the array. I'm going to put the function at the top above main because I said that we can do the definition above main, or we can do the definition below main and then put the declaration or the function prototype or the signature across the top. So I'm going to create a function above main called square array. I'm going to pass to it an unsized array as well as an integer size. I'm just going to loop through it, and for each element in the array, I am going to multiply it by itself. And then we're going to come down into main and we are going to call it. And all I have to do is call it by name. And then pass to it the array or my array. And then we would certainly like to display the results. So for the display of the results, we don't have to return the array because it is an array. I'm just going to loop through the elements of the array and print them out one at a time. And let's see if we did double or square, the elements. All right, so before it'll run, we're going to have to pass it the size. We have that size variable there. So now let's see if it will run. Once we have passed the size, the array and the size in the function call. And let's see if it doubled it. There it is. So we can pass array elements to a function. We don't have to return values. So how about if we try a vector? So I'm going to declare a vector called my vector, and I'm going to push some integer values on it. In order to use the vector, we're going to have to pound include vector. And then I am going to create a function that is going to square each one of these individual values. Now we said that there are 2 options available to us. One is to pass it by value. So the first function is going to pass the vector by value. So I'll create this function above main as well. The return type is going to be a vector, double. We're going to call this one square vector. I'm going to pass to it a double vector as well with the name vectparm. This vec size, I'm actually going to create a global variable. And we'll call it, we'll make it a global variable of type int. We'll call it vec size. All right, so this one should be happy. Global means I'm just declaring it outside of main so that I can use it inside of main and any of these functions as well. So in order to get the vector size, I'm just going to use the size function out of the vector library. I'm going to loop through my vector, and I am going to multiply the vector element by itself. And then I'm going to use a return keyword, and then we're going to come down here and call the vector, call the function. And so to call the function, I am just going to, we called it square vector. I'm going to pass to it my vector. And it is returning to me a vector. So I am going to capture the return value in return vector. Created 2 vectors of the same data type or of the same vector type. So that's where I'm going to capture it, and then we will print out the value. So once again, I'm going to have to calculate the size of the vector so that I can loop through each one of the elements of my vector, and I'm just going to print it out. And let's see. So it did square each one of the elements. So we said that we could pass it by reference or by value. And so this is passing it by value. So I'm going to copy and paste this, and I'm just going to make a couple of changes. Let me pass that down, because this time we're going to pass it by reference. And I am going to comment this one out. And then I'm just going to make a couple of changes to it. First of all, I'm going to remove the return value. And then the next thing I'm going to do is put the ampersand at the end of the data type. And because we're doing that, I don't have to return anything anymore. So I'm just going to remove the return. So I don't need a return keyword. I don't need a return value. And I'm going to make sure that I have that ampersand at the end of the data type, which means that I am going to call it a little bit differently as well. So I'm going to copy the call and the print statement. We'll copy it, and then we will paste that, and then I will comment out my original, because we're going to have to call it and print it just a little bit differently. All right, so since it's not returning anything to me, I don't have to capture anything, which means that this time, since I'm not capturing anything, I just need the size of my original vector, and I am also going to print out my vector. And then we'll run it and see if we are still getting the square of our original value. All right, so instead of returning a vector, I'm going to use the keyword void on my function. I'm going to replace the vector return with the void keyword, and now I'm seeing that it is indeed squaring it. So the difference was that I'm returning void, and now when passing it by reference, I don't have to return anything, which also means that I don't have to capture anything. All right, so how about if we try structs next? So we're going to start over, and we are going to create a struct outside of main. I'm just going to give it a couple of members, and then we're also going to do the same thing. We're going to create a function that will pass by value, a structure, and then we're going to see if we can get it to pass by reference as well. So I have several struct variables, one called singles, one called doubles. I'm going to go inside of main, and I'm going to create I'm going to set the singles struct data types, and then we are going to create a function that will square the values in each one of these three struct members. So we'll call this one the same thing. We'll call it square struct this time. I'm going to pass to it my struct, and I'm going to return a struct, which means that the return value instead of void is my the name of my struct. And then we're going to come down here and call it, and we're going to print it out. So I'm going to call the function square struct. I'm going to pass to it singles. I'm going to capture the return value in doubles, and then I'm going to print out the three values in doubles. I'm just going to use the printf, because that would be a lot of couts if I were going to do them one at a time. And so in order to use printf, there's possible that I'm going to have to come up here and pound include stdio.h. Depending upon the platform that you're using, you might have to pound include stdio.h. And then I'm going to come back down here, and we're going to run it. So it should say a text field of 1, 2, and 3. If you remember what the switches were inside of it, a dash. If I put a number inside of there, it'll set my field width. If I put a dash in front of it, it is going to left align it. No dash would right align it. So there we go. It runs. It's interesting. I see the 1, 2, and the 3. It's interesting. Then I multiply a semicolon or a colon by itself. I get a $sign. Very interesting. So now we're going to come up here, and we're going to see what kind of changes that we have to do to pass by value. So I'm going to copy the function. I'm going to comment out the original, and then we'll make just a couple of necessary changes to the new one. Once again, instead of returning numbers, we're going to return void. We're going to pass it by reference, and so I am going to change this to passing it by reference, and then notice that it's unhappy because I said return void, so I'm going to remove the return value, which means that I'm also going to come down here, and I am going to comment out. Let me copy my call and my display. My call on line 50 is unhappy because that function does not exist now that has a return value. So the changes that I make, well, because I'm not returning anything anymore, I'm just going to call it by name. And since I am manipulating or modifying the original value of singles, I'm going to have to change what I am printing to singles. Since I'm no longer capturing it, we're going to change each one of those to singles. And when I run it, this time I didn't have to return anything. I didn't have to capture the return value, but it did indeed modify my original value. So I'm going to add one more thing to this program. Since we're using printf and I was talking about the switches, I'm actually going to add a link to this, a really good resource on c++.com that will show us a variety of different. This is the website, and it shows us a variety of the different parameters that we can put in there. The C for character, the D for decimal or whole number, the F for float. And it also shows the flags or the switches that we can use. Here was the dash flag that I was using. Right, justification is default, so if I wanted to left default within a field width. Anyway, this is just a really good reference for the flags that we use on printf. So I will include that. So how about the last thing that we're going to do, now that we have done arrays and vectors and structs, how about if we finish off with enums? All right, so we're going to try enums. So I have created an enumerator called numbers. I've set some values to it. And then I have created a function which once again is going to square each one of the elements in it. I'm going to initially pass it by value. So it is going, I'm going to use the return keyword to get back. And inside of it, all I really need to do is to return 25. So I kind of manually doubled it because I created a numbers variable called 5 and I kind of manually doubled it to 25. I created a second numbers variable, and that is the value that I'm going to catch it. So on line 29, I'm doing the function call to square enum. I'm passing my singles enum, and I'm capturing it in doubles, and then I'm using printf to just display the doubles. And what it should do is it should double it, hard-coded doubled it, to 25. And so here it is, 25. So we can see that it works if I pass it by value. So now I am going to copy and paste not only the function, but the call in the display to see if we can pass it by reference instead. So the first thing that I did was I copied my original function, commented it out, I pasted it, I removed the return type, replaced it with void, and then put the ampersand in front of the data type. Then the next thing that I did was remove the return statement and just set my parameter to 25. And then I also did the same. I copied and pasted the function call and the display itself, but this time instead of capturing a return value, it is modifying my original. So I am printing my original, and when I print it, this time it's going to give me the same value, that it has been doubled to 25. So this is just a very simple example of how we can pass a variety of different data types to functions and also capture the return value.